This is an example of how to implement a queue by utilizing two stacks. For the sake of example, these labels on my desk will represent stack number 1 and stack number 2, respectively. And each of these games will represent items to be added and taken away from each of these stacks. In order to emulate the enqueue method, we will really only need one of these stacks that we have created thus far. We will use stack number 1 for this. To enqueue an item, we simply push the item into stack number 1. This is the only step needed to do this, and for the sake of later methods, we will enqueue 3 other items to stack number 1, those being B, C, and D. For the dequeue method, we will assume that we already have the 4 items enqueued into stack number 1 from earlier, as the queue works in a first in first out basis, and thus an item that gets dequeued must be the first item in, or the item at the very bottom of the stack. In order to do this, we must pop each item and push it into stack number 2. This effectively reverses the order of the first stack and makes it to where we now have access to the first item. And we can pop that item and return its value, dequeuing the item in the process from our implementation. It is also important to move all the other items back to stack number 1 in the original order, doing the same thing as earlier but in reverse, so we can work under the assumption that the stack is still in this order for all further methods. For the first method, we're using the same idea that we did for the dequeue method. We pop each of the items from stack number 1 and push them into stack number 2. We now have access to the first item in this stack. However, instead of popping the item from the stack, we simply get the value that it holds, which is B, and return that value. As before, we then move all of the items back to their original place in stack number 1, just because it makes things easier for other methods. For the isEmpty method, it works very similarly to the corresponding method for stacks. All of our queue items are stored in stack number 1 by default. So, we simply check and see if stack number 1 is empty. In this case, stack number 1 is not empty, so we would return false. The size method is also very similar to the size method for stacks. We simply get the size of stack number 1 where our items are stored and return the value. In this case, we have 3 items in stack number 1, so the value that this would return in this case would be 3. The toString method is probably the most involved of all the methods implemented thus far. We start off the same way that we started both the dequeue and first methods, by moving all the items out of stack number 1 and into stack number 2. At this point, we must get the value from each item and add it to our initially empty string, and then we move it back to place in stack 1. So the value from this item would be B, so we would add B to our string. The value for the second item is C, so we would add C to the string. And the value from the final item is D, so we would add D to the string.